Today we're going to be talking about more volume formulas. We're going to be discussing the formulas for cylinders, cones, and spheres. The materials you will need are probably a ruler, a calculator if you have one, and a pencil, something to write with. So our standard for this one is know the formula for volume of cylinders. So the first thing we need to know is, what does a cylinder even look like? So here it is, okay? So a cylinder is pretty much, if you think about real life, it's a can, okay? It's a can. Here we have one right here. There, the circles are the bases, and then it wraps around. So you do need to remember a couple of definitions when you are talking about circles. So what we're going to start with is definitions. The first thing you need to know, here, I'll just open them up. The first thing you need to know is pi. So if you remember pi, it's approximately equal to 3.14, and it is a constant. That means it is always going to be 3.14, or that's the abbreviation we will be using, because really pi goes on forever and ever and ever, and it never ever ends. It's defined as the ratio of a circle's circumference to its diameter. So that's the official definition. Anytime you see a circle, you will be using pi. Also, anytime you see a circle, you will also have a radius or a diameter that is shown. So the radius is a line segment from the center to the perimeter of a circle. So if you notice right here, you start at the center and then you go to the edge of the circle. That's the radius, okay? The radius is also half of the diameter, making the diameter the entire line segment straight across the circle. So the diameter would be from this end to this end. It would be the entire line segment. So that's the diameter. So these three things you will always be using when you are dealing with any shape that has a circle in it. So, like I've said before, volume formulas kind of stem from area formulas. You just have now a third dimension. So the formula for the volume of a cylinder is V is equal to pi r squared h. So you have pi, you have the radius, and you have the height. The little 2 is an exponent of 2. It means you're squaring the radius. Excuse me. So here we have two examples. Let's go ahead and start with the first one. The first thing you always do, yeah, you can draw your figure, but then you always have to write down the formula, because you have so many figures, you don't know which formula to use. So that's why I always write down the formula, so I know that this is the formula that I'm using. And then I fill in what I know. Sorry, I'm losing my voice. Okay, so I know that pi is always equal to 3.14. That never changes. It's approximately equal, okay? In this example, our radius is whatever is in the circle. So in this case, from the center to the end, we have the number 4. So I'm gonna go ahead and square it, 4 squared. And then I know my height is 12. So now that I have everything filled in, I will take, well, the first thing I need to do is, I know that before multiplication, I have to get rid of the exponent. So the exponent is 4 squared. That's not 4 times 2, that's 4 times itself. So 4 times 4 is indeed 16. And then I just write everything I didn't use. And then I'm gonna take my calculator. This is my favorite calculator to use. And I'll plug in 3.14 times 16 times 12, and I get volume is equal to 602.88, and then we have to label it in units cubed, so inches cubed. You will be rounding, now that we have pi, which is a decimal, okay, you will have decimals in your answer, and just round to the hundredths place. That's 2 numbers after the decimal. So for this cylinder, volume is equal to 602.88 inches cubed. All right, next example. I'm gonna go ahead and write down my formula just so I have it written. And here I have a cylinder that's been flipped on its side. Okay, so let's plug in everything we know. Oh, here, let me. So I know pi is 3.14 always. Looking at this example, I need my radius. I kind of tried to trick you here, okay, because I gave you the entire line, which means this is the diameter, and I don't need the diameter, I need the radius. So how do I find the radius? Well, I know the diameter is 6, and per the definition, the radius is half of the diameter, so I'm going to take half of 6, which is 3, and I'm going to square it, and I know my height is 8. So of course I have to do the exponent first. So 3 squared is equal to 9 because that's 3 times 3. And then I'll bring down everything I did not use. And then I'll put my calculator down. And I'm going to go ahead and do 3.14 times 9 times 8. And that is equal to, volume is equal to 226.08 yards cubed. And that's how you find the volume of cylinders. Please write down the definitions before you do anything, and please write down the formula before you do anything as well. Okay, moving on to the next formula, we have cones. So now we're going to find the volume of cones. Okay, so here's what a cone looks like. Think of a snow cone at the fair. Okay, you have a circular base and then you have a tip at the end. Okay, this is a snow cone. This is just a flipped cone. Okay, you still, since you have a circle, you have a radius, you also have a height. You also need to remember that pi is approximately equal to 3.14. Now the volume of a cone formula is pi r squared h divided by 3. Now I also wrote this formula here in orange because if you were to ever Google the volume formula for cones, this is what you would get, okay? This is what you would get. But I want to remind you that multiplying by 1/3 is the same thing as dividing by 3. The reason I give you the formula here in green, the one that I use, because I think it's easier to multiply everything out and then divide by 3 so that you're not dealing with a fraction. However, you can use either one. Again, we're going to do a couple of examples. So here we go. I'll go ahead and open this up. The first example is a cone that's been flipped on its side. So you know your radius is 1, you know your height is 11. And again, as you can see, I have the volume formulas written out before I do the problem. So I'm going to go ahead and fill in everything I know. So I know that pi is 3.14. Okay, that does not change. Now looking at my radius, the radius is usually the number, not usually, it is the number inside the circle, which is 1 squared. And I know my height is 11. And then I have to divide everything by 3. Okay, so I have to get rid of the exponent first. So 1 squared is 1 times 1, which is 1. Okay, that's pretty simple math right there, divided by 3. I'll have my calculator over here just so we have it, okay? Then I have to multiply it out. 3.14 times 1 times 11 is equal to 34.54, and then I still have to divide by 3. So I have volume is equal to 11.51, oh, not yards, feet. Oops, let me delete that. Feet, delete, let me erase that, feet cubed. Okay, now you look at this problem, it's 11.51333333 goes on forever and ever, but when we round to the hundredths place, we look at the next number. If it's less than 5, we leave it. If it's more than 5, we make this go higher. However, 3 is less than 5, so we leave it as 11.51. So the volume of this cone is 11.51 feet cubed. All right, moving on. Next problem. Let's fill in everything we know. Our diameter is 18 meters. Our height is also 18 meters. And we know that pi is 3.14. Now looking at this problem, again, tricky. You have a diameter. The entire line is 18. We need the radius. So if you remember, the radius is half of the diameter. So we need half of 18, which is 9 squared. And our height is 18 divided by 3. So 9 squared is 9 times 9, which is 81 times 18. And then I fill in everything. Oops, divided by 3. I'll go ahead and get my calculator out here. So then I do 3.14 times 81 times 18, and that equals 4,578.12 divided by 3. Yeah, it's a big number. Yes, you have decimals. I divide by 3. So my volume for this cone is 1,526.04 meters cubed. Remember, you always oops, oh my goodness, I'm sorry. You always label volume in units cubed. I'll go ahead and leave this up for just a second. Feel free to pause the video at any time to write down what you have missed. Okay, and lastly, we have the sphere. Here we go. Here's our sphere. Forgot to label the radius. Okay. So here's our sphere. Our standard is A.G.9. Know the formula for volume of spheres. And this is what a sphere looks like. It's obviously just a circle. So think of any ball, really, like a golf ball or a basketball or anything really. So that's a sphere. And again, pi is approximately equal to 3.14. And the volume formula for a sphere is 4 pi r cubed divided by 3. Or if you were to Google it, the volume would equal 4/3 pi r cubed. Literally the same thing. You can use either one. I just find it easier to multiply everything and then divide by 3. And here I have 2 examples for you that I did not finish. So let me go ahead and finish those. Let's make this 3 inches and let's make this 10 meters. Why not? Okay, so let's go ahead and do the first one. Of course, what you're going to do always is you're going to write down the formula 4 pi r cubed divided by 3. Yeah, we don't really have a height here. So 4 stays, that's just a number. We know that pi is 3.14, and in this example, the radius from the center to the edge of the circle is 3, so I'm gonna go ahead and plug that in, and then I'm gonna divide by 3. And then I'm gonna do the exponent first, so it's a power of 3. So now you take your base and multiply it 3 times, so 3 times 3 times 3 is what? 3 times 3 is 9, and 9 times 3 is 27. So you have 431.14 and 27 divided by 3. So then you go ahead, oops, let me scoot this up. I always forget to do that. So then let me go ahead and take my calculator and multiply 4 times 3.14 times 27 and then divided by 3, which equals 113.04 inches cubed. So multiply it out and then divide by 3. So the volume for this sphere right here is 113.04 inches cubed. All right, next sphere, and we have a diameter of 10 meters. Let's do millimeters because meters is so large. So the volume again is 4 pi r cubed divided by 3. When numbers and variables are right next to each other, you have to remember that that means multiplication. So then we fill in what we know. 4 is a number, so it stays. Pi is 3.14, and in this case, our radius. So in this case, we have a diameter of 10, making the radius half of 10, which is 5 cubed divided by 3. So then we have to do the exponent. Okay, so 5 cubed means 5 times 5 times 5. So 5 times 5 is 25, and 25 times 5 is 125. And then we write down everything we did not use. And now we take our calculator, we do 4 times 3.14 times 125. Oh my goodness, this is gonna be a huge number. So 1,570. 4 times 3.14 times 1, I'm just double checking, and then I divide by 3. So volume is equal to 523.33 millimeters cubed. So as you notice, whenever you have, oh my goodness, here you go. As you notice, whenever we have any type of circle in our figure, we're always going to be dealing with pi, and we're always going to be dealing with the radius. So these are examples for the spheres. So we just went over cylinders, cones, and spheres. And if you have any questions, please feel free to let me know.